let me show you some tricks that you should be aware of when integrating one polynomial over another polynomial. So in the previous video, I asked you always keep an eye out on something being the derivative of another thing. So always keep an eye out on something being the derivative of another thing. So if you integrate this, it will give you the natural log of the bubble. So always try and keep an eye out on this. Okay. So now let's look at this example. If you try and integrate this, let's try and break this up into two fractions. So we could use long division, but here's another way. Here's an alternative to using long division, because long division is quite time consuming. So an alternative is that, well, this being very similar to this, let's break it up like this: x squared plus 2x plus 1. And then over here, well, here you can see you've got a 4x here. At the moment, we've got 2x, so make the adjustment over here. So this here is a block of 2 here, and then here we've got 1, but then but here up here we've got 8. So let's make the adjustment 7 here. So now if you get this plus this, it will give you this. So rather than using long division, we can just look at this here. This is one block here. This here is one block. If you add the two together, it will give you 4x. If you add this and this together, it will give you 8. And then this here is the same as this. Okay, so the point is that rather than using long division, we can just do it like this. Sometimes it's easier. Okay, so this whole thing here is 1, because exactly the same divided by exactly the same, it will give you 1. So this whole thing here, so this whole thing here will be this. Okay. So now that we're here, look at this here. Remember from the previous video, try and keep an eye out on something being the derivative of another thing. So if you look at this here, the derivative of this is 2x plus 2. But this thing here is very similar to this. So let's make the adjustment to this fraction in such a way that we will have the derivative over we are going to try and get this to be of this form here. So hang on. So looking at this here, the derivative of this is 2x plus 2. So let's make the adjustment here, because these two are very similar. So let's make the adjustment. So looking at this, we are trying to get this form here. This being the derivative of this. So if you look at this here, the derivative of this is 2x plus 2, and then now make the adjustment, because we are trying to break this fraction up into this fraction plus this fraction here. But we are going to rewrite it as this. Hang on, we've got 2x here. That matches up with this. But then this 2 here is, well, we need to add a 5 here, because if you get this plus this, it will give you 7. So the point is, let's break this up into this fraction plus this fraction. Now the good thing is that this thing here is a derivative of this thing here. Okay, so break this up into this fraction plus this fraction. So that would then take us to here. Okay, so notice that this now is the exact derivative of this. So now we can just integrate. Let's integrate. Integrate this, it will give you x. Now because this thing here is the exact derivative of this, so when you integrate it, it will give you this thing here. Okay, and then integrate this. Visualize it as when you integrate this, it will give you this, because you would visualize integrate this, it will give you this. Okay,